Winter, 1873. The Allegheny Valley Ironworks stood along the river bend where coal barges queued at dawn, and the sky above the valley ran grey with furnace smoke. Inside the main foundry hall, reverberatory furnaces burned day and night, their arched brick chambers glowing with reflected heat. These were not blast furnaces. They were melting furnaces, designed to refine pig iron into usable castings through radiant heat alone. Flame swept across a shallow hearth, never touching the metal directly. Heat bounced from the curved brick roof down onto the charge below. Iron softened. Slag separated. The process was understood, routine, and predictable, or so it seemed. Day shift began before dawn. Men arrived with coal dust still in their lungs from the previous evening, their boots heavy on the foundry floor. The reverberatory furnaces had been loaded the night before. Broken pig iron, scrap rail, fragments of old castings. Each charge weighed nearly 2 tons. The furnace doors were sealed. Fireboxes roared with anthracite fed by hand. Flames licked horizontally across the low brick roof, radiating downward onto the iron below. The metal did not sit in the fire. It sat beneath it, heated by waves of reflected energy. By mid-morning, the charge had begun to soften. Workers peered through observation ports, their faces lit by the orange glow. Slag rose to the surface, a glassy scum that would be skimmed away. The iron beneath turned glossy, viscous, beginning its slow collapse into liquid. This was expected. This was normal. The fire did its work, and the iron responded. Foreman William Tarbell walked the line of furnaces, checking dampers, noting fuel consumption, watching the men for signs of carelessness. He had worked iron for 20 years. He knew the rhythm of the furnace, the way heat built, the way metal yielded. Fire was the engine. Without flame, there was no melting. That was the law of the trade. By late afternoon, the charge in Furnace 3 had fully liquefied. Tarbell gave the order. The furnace was tapped. Molten iron poured into ladles, glowing white at the edges, darkening as it flowed. The pour was clean. The metal would be cast into machine parts, gears, brackets, the bones of industry. The hearth was raked, the slag removed, the brickwork inspected. Everything was as it should be. But Furnace 7 had not progressed as planned. The charge had softened unevenly. Portions remained stubbornly solid. The decision was made to shut it down. There was no saving a partial melt. The iron would be reloaded the following day. Tarbell ordered the firebox damped. The coal feed was stopped. The furnace doors were left sealed. The fire was allowed to die. The men moved on. Afternoon became evening. The foundry floor grew quieter. Furnace 7 sat dark and silent, its interior cooling, its failed charge abandoned. Shutdown was a deliberate process. It was not simply a matter of walking away. The firebox damper was adjusted to choke off the draft. The ashpit door was closed. Residual coal was left to burn itself out, but no fresh fuel was added. The furnace was not opened. The charge was not disturbed. The brickwork was left to radiate its remaining heat into the air. Within an hour, the flames had guttered and died. Within 2 hours, the interior was dark. Tarbell made a final inspection before leaving for the night. He touched the outer wall of Furnace 7 with the back of his hand. It was hot, but not dangerously so. The brickwork was doing what it always did, holding heat, releasing it slowly. He noted the furnace number in the logbook. Shutdown time, 6:20 in the evening. Condition, cooling normally. Expected status at morning, cold hearth, solidified charge. The night crew arrived at 8. Their job was maintenance, not production. They tended the active furnaces, monitored the casting floor, ensured nothing collapsed or caught fire. Furnace 7 was not their concern. It sat in the row with the others, a dark shape among glowing neighbors. No light came from its observation ports. No heat shimmered above its stack. It was a dead furnace. The foundry settled into its nighttime rhythm. The hiss of steam, the clang of tools on anvils, the low roar of the furnaces still in operation. Furnace 7 was forgotten. At midnight, one of the night crew, a man named Howell, passed near Furnace 7 on his way to the coal bins. He paused. Something had caught his attention. He stepped closer. The outer wall of the furnace was warm, not cold, not even cool. Warm. He placed his palm flat against the brick. Heat pressed back. Howell frowned. Hours had passed since shutdown. The furnace should have been losing heat steadily. He walked around to the firebox. The ash pit door was closed. No glow came from within. He checked the damper. It was set as Tarbell had left it. He moved to the observation port and opened the iron shutter. Darkness, no flame, no ember light. The interior was black. He closed the shutter and walked away. The warmth, he decided, was simply residual. Brick held heat. Everyone knew that. It would fade by morning. The day shift returned at 5:30 in the morning. The sky was still dark. Lanterns swung from iron hooks along the foundry walls. Tarbell arrived with the others, his breath misting in the cold air. He moved down the line of furnaces, checking each one. Furnace 7 was on his list for reloading. He expected to find it cold, the charge frozen in place, the slag hardened into a useless mass. He opened the observation port and looked inside. The iron had moved. It had not simply remained where it had been the night before. It had flowed. Portions of the charge that had been semi-solid at shutdown were now slumped, collapsed, spread across the hearth in ways that suggested continued softening. The edges of the slag pool had extended. Metal that should have frozen in place had instead sagged further. Tarbell called for another man. Together they stared into the furnace. There was no flame. There was no glow. The interior was dim, lit only by their lanterns. But the iron had changed. It had continued to melt after the fire had died. "Did someone relight this?" Tarbell asked. The other man shook his head. No one touched it. Tarbell walked to the firebox. He opened the ash pit door, cold ash. No coals, no ember glow. He checked the damper, still closed. He returned to the hearth and placed his hand near the furnace wall. Heat radiated from the brickwork, not intense, not blinding, but present. Hours after shutdown, the furnace was still warm. He called the night foreman. "Did your men fire this furnace?" "No, it was shut down. We left it alone." "Then explain this." The night foreman looked inside. He saw the same thing Tarbell had seen. Iron that had moved, slag that had flowed. He had no explanation. Word spread quickly. Workers gathered around Furnace 7. Some touched the walls. Others peered through the ports. The furnace was warm. The iron had softened, but there had been no fire. Accusations began before the morning was an hour old. Someone must have relit the furnace. Someone must have violated procedure. The night crew insisted they had done nothing. The day crew insisted the furnace had been properly shut down. Tarbell stood in the center of the argument, his jaw tight, his patience thinning. "Check the coal bins," he ordered. "Count what's been used." The count was made. The numbers matched. No unaccounted coal had been burned. The night crew had used exactly what was expected for the active furnaces. Nothing extra. Nothing diverted to Furnace 7. "Then someone brought their own fuel," one man said. "Why?" another shot back. "Why would anyone waste time and coal on a ruined charge?" No one had an answer. Tarbell inspected the furnace again. He opened the firebox door fully, letting daylight into the chamber. The firebricks inside were streaked with ash, but there was no sign of fresh burning. No unburned coal fragments. No soot patterns that would suggest a recent fire. The furnace had not been relit. He was certain of it now. But that left the question unanswered. How had the iron continued to soften? The superintendent was called. He was a man named Grayson, older than Tarbell, with a reputation for strict enforcement of foundry rules. He arrived with a ledger under his arm and suspicion in his eyes. He listened to the reports. He examined the furnace himself. He questioned the night crew individually, looking for inconsistencies. He found none. "This furnace was shut down correctly," Grayson said finally. "No one relit it. No one tampered with it, but something happened." The men waited. "I don't know what," Grayson admitted, "but we're going to find out." Grayson ordered the furnace left untouched for the rest of the day. No reloading, no disturbance. He wanted to observe how it behaved as it cooled. Tarbell was assigned to monitor it. Every hour, he recorded the temperature of the outer walls using his hand and his experience. There were no thermometers precise enough for this work. Heat was judged by touch, by proximity, by the way air shimmered or skin reddened. The furnace was still warm at noon. It was still warm at 2 in the afternoon. By 4, the heat had diminished, but not vanished. The brickwork radiated a persistent warmth that refused to die. Tarbell stood with his hand against the wall and tried to understand what he was feeling. Brick held heat. He knew that. Every furnace worker knew that. The masonry of a reverberatory furnace was massive, built to withstand and contain extreme temperatures. The walls were thick. The roof was arched and heavy. All of that material absorbed heat during operation. All of it had to release that heat when the fire was extinguished. But how long did that take? Tarbell had never thought about it before. Furnaces were either hot or cold. There was no in-between in his mind. A furnace was fired or it was not. Once the fire died, the furnace cooled. That was the assumption. But the assumption was wrong. He walked around the furnace slowly, touching different sections of the wall. The heat was not uniform. Some areas were warmer than others. The sections closest to the hearth were the hottest. The sections near the stack were cooler. The furnace was not cooling evenly. It was releasing its stored energy in layers, in zones, in a slow and uneven bleed of warmth. And that warmth was not disappearing into the air. Some of it was radiating inward, back toward the hearth, back toward the iron. Tarbell opened the observation port again. The iron was still there, still slumped, still soft in places. It had not melted further, but it had not frozen solid either. It was caught in a state of partial liquidity, sustained not by flame, but by the lingering heat of the furnace itself. Grayson brought in an engineer. His name was Aldrich, a man who had studied furnaces in Pittsburgh and consulted on foundry design. He arrived the following morning with a notebook and a set of calipers. He spent an hour examining Furnace 7, measuring the thickness of the walls, inspecting the arch of the roof, studying the layout of the firebox and hearth. He did not speak much. He took notes. When he was finished, he addressed Grayson and Tarbell in the superintendent's office. "The furnace is a heat reservoir," Aldrich said. "The masonry stores energy. During operation, the brickwork absorbs heat from the flame. When the fire is extinguished, that heat does not vanish. It remains in the brick. It radiates inward and outward toward the hearth, outward toward the air." Tarbell frowned. "But the fire was dead. How does brick melt iron?" "It doesn't melt iron on its own," Aldrich said, "but it can sustain a temperature high enough to keep iron soft if the iron was already near its melting point. The charge in Furnace 7 was partially molten when you shut it down. The residual heat in the walls was enough to prevent it from solidifying immediately. In some cases, it may have been enough to allow further softening." Grayson leaned back in his chair. "You're saying the furnace melted iron without fire?" "No," Aldrich corrected. "The furnace transferred stored heat to the iron after the fire was gone. The fire provided the initial energy. The masonry held that energy and released it slowly. The iron received heat in 2 phases, directly from the flame and later from the heated structure itself." Tarbell considered this. So the brick was acting like a second fire. Aldrich nodded. "In a sense, yes. A weaker fire, a slower fire, but fire nonetheless." Aldrich explained further. The phenomenon was not unique to Furnace 7. It occurred in all reverberatory furnaces to some degree. The difference was that most charges were either fully melted or fully solid by the time shutdown occurred. Furnace 7 had been caught in the middle. The charge had been on the edge of liquidity, and the stored heat in the walls had been enough to push it over. "The key," Aldrich said, "is thermal mass. The heavier the structure, the more heat it can hold. Your furnace has walls nearly 2 feet thick. The roof is arched brick, just as thick. That is an enormous amount of material. It takes hours to heat fully during operation. It takes hours to cool fully after shutdown. During that cooling period, the furnace is still a source of heat." He drew a diagram in his notebook, a cross-section of the furnace, arrows showing heat flow. During operation, heat flowed from the flame to the brick to the iron. After shutdown, heat still flowed from the brick to the iron. The process was slower. The temperatures were lower, but the transfer continued. Heat moves from hot to cold, Aldrich said. As long as the brick is hotter than the iron, heat will continue to move toward the iron. If the iron is already close to its melting point, even a small amount of additional heat can cause it to soften further. Tarbell asked the question that had been bothering him since the discovery. Why don't we see this more often? You do, Aldrich said. You just don't notice it. Most of the time, the charge is removed while the furnace is still hot, or it's left to cool completely and the final state doesn't matter. But in cases like this, where the charge is borderline and the shutdown timing is precise, the effect becomes visible. Grayson tapped his desk. So there's no mystery. No mystery, Aldrich agreed. Only misunderstood heat behavior. Aldrich spent the rest of the week at the foundry, conducting tests. He measured the cooling rate of the furnace walls using metal probes inserted into the brickwork. He tracked the temperature of the hearth over time. He recorded the state of test charges left in the furnace under controlled shutdown conditions. The results were consistent. The masonry of Furnace 7 held heat for more than 12 hours after the fire was extinguished. During the first 6 hours, the temperature inside the hearth remained high enough to prevent iron near its melting point from solidifying. In some cases, if the iron was already semi-molten, the residual heat was sufficient to cause additional softening. The phenomenon was entirely mechanical. No hidden embers were required, no secret relighting, no sabotage. The furnace itself was the source of the continued heat. The brickwork acted as a reservoir, slowly releasing the energy it had absorbed during the firing cycle. That energy radiated inward, reflected off the curved roof, and transferred to the iron through conduction and radiation. Aldrich wrote his findings in a formal report. He explained the concept of thermal mass. He described how radiant heat could persist in enclosed masonry structures. He outlined the delayed transfer of energy from brick to iron. He provided calculations showing the rate of heat loss and the minimum temperature required to keep iron plastic. Grayson read the report twice. Then he filed it and called a meeting with the foundry supervisors. We've been treating the furnace as if it's only hot when the fire is burning, Grayson said. That's wrong. The furnace stays hot long after the fire dies. We need to account for that in our procedures. New rules were established. Shutdown times were recorded more carefully. Charges near the melting point were not left in cooling furnaces unless they were intended to be remelted. Workers were trained to understand that heat did not vanish the moment the fire was extinguished. The furnace was a system. Fire was only one part of it. The incident at Furnace 7 became a teaching case. Aldrich published a paper on the subject in a Pittsburgh engineering journal. Other foundries wrote to the Allegheny Valley Ironworks asking for details. The phenomenon was not unknown in the broader sense, but it had rarely been documented so clearly. Most foundrymen operated by intuition and tradition. They knew furnaces stayed warm. They did not think deeply about why or how. Tarbell continued his work at the foundry, but his understanding of the process had changed. He no longer saw fire as the only source of heat. He saw the furnace as a whole system: flame, brick, iron, air, time. Each element affected the others. Shutdown was not an ending. It was a transition. The furnace did not stop being a furnace just because the fire went out. Years later, when he trained younger men, Tarbell would take them to a furnace at the end of a shift and have them place their hands on the walls hours after shutdown. Feel that, he would say. That's stored energy. That's heat the furnace is still giving up. If there's iron inside, that heat is still working. Remember that. The younger men would nod, unsure if they fully understood, but they remembered. The foundry continued its work. Iron was melted, cast, and shipped. The reverberatory furnaces burned as they always had, but the men who tended them carried a new awareness. Fire was powerful, fire was essential, but fire was not the only force at work. Heat could persist. Heat could linger. and in the right circumstances, heat could finish what the fire had begun, even after the flames had gone dark and cold.